And it should be streaming. And let's have a look at the channel, see if it is live. What am I doing? No. There we go. Brilliant. Okay, so that's sort of how it works. Events. Go to the event page and then you get redirected to the live stream. Okay, sounds safe enough. Let's turn the volume off. There we go. Amazing. Okay, so hello everyone. I am Leandro and I am here in Reasonable Coding. I'm going to be adding some features to Cactus. Cactus is a static site generator, a composable static site generator in the spirit of the Dune build tool, opening it here in GitHub so you can have a look. It's a tool I started working on the past week or so due to A, being sick at home, and B, not being very comfortable with how most static site generators tend to enforce their structures on you. But also C, because I really wanted to dig more into building applications and tools with Reason and the OCaml toolchain. This is a Reason project. You can see here, well, it's going to say OCaml. It also says C++. I have no idea why, but most of the coding here is just Reason code. There's some RE files here. In fact, if I just do, you'll see most of the coding source is just Reason, and if I open any of this, you'll see, let's say the build graph. It's just data types and functions and recursion and your typical Reason stuff, so not too scary. Not too scary. But yeah, I've been learning a lot from it. I've been getting a lot of help from Antron and Montero as well, particularly on Montero when it comes to parallelizing the workload and making this tool very fast. So yeah, long story short, if you have a directory tree that looks like this with some markdown inside of folders, and you want to turn this into a website, you can just create some files saying, hey, there will be a project at the root of this directory by marking a Cactus project, and then mark the folders that you want with sites, and then Cactus will just automatically find the places and the things he has to compile and compile them over. But I've been saying this for the past few streams, so if you wanna go back 3 live streams and have a look at those, then you'll get more context. Today, what I want to do is to be able to wrap each one of these rendered HTML files into a template. Because right now, when you compile this markdown into an HTML file, and I'll show that in a second, you only get exactly what's on the markdown file. You get nothing more than that. So I am here in this website, which is a sample project, very similar to the one that we have on the README. You'll see a new project and pages and sections. Oh, by the way, I just bumped up the resolution of the screen recording. So if it looks good, please let me know. If it looks like shit, please let me know as well, so we can fix it on the way as we go. Okay, just give me 1 sec. I'm gonna go into the dashboard mode of Twitch. Cool. So now I can read your comments if you say something. Say hi. Cool. So if I open, as you can see here, this first post MD, they got compiled into a first post.html. So if I open that public pages first post.html, you'll see that, oops, it's empty. Let's build it. Huh. Is the markdown file empty? Okay, I was so worried for a second there that everything got really terribly broken, but it didn't. Oh, we have a hi. Hey, Herculine, how's it going? So I am going to just iterate over this with you here. I'm gonna make a first post. I'm just gonna say hello world, and this is just a blog post, and yeah. So we have some markdown content here. I'm gonna open a small terminal below so we can compile this fast, hopefully fast enough. Cactus build, boom. And if I open this in public and then pages, it has the same structure as the sources. And then first post, you'll see that we have the contents here. We have a blog quote, right? And then inside there we have a paragraph and we have an H1, which is the one that we have here. We could also do subtitle, I mean any amount of markdown that we want, and you can see this got automatically, this got built. Cool, but some of you may notice that this thing here, while it's valid HTML, it doesn't really look like a valid HTML project or like document where you have the HTML tag and then you have a head and then you have some headers, right? And oops, and then you have a body, and then you would have the content, and by the end of that, you will close the body and you will close the HTML tag. So there's a few things we could do here. Like first of all, we could assume that all posts will automatically be should be wrapped in this precise content, the bare minimum, right? But then if you wanted to change the title, then you would have to like go into each one of the posts and manually in the HTML compile file and modify that, and that sucks. If you wanted to include some JavaScript, then you would have to do the same thing. If for some reason you did not want this to be wrapped around in HTML, say that you just want to have these files over here so you can I don't know, parse them and make sense out of them in a different way. Let's not forget that HTML has the ability to let us structure content in a semantic way, so that we know if we read this into a program, right? We could. I'm gonna open a small split over here. If we open this into a program, we could easily say there will be something called a document, and I'm just gonna use recent syntax for and do some polymorphic variants. So a document, and the document could have like its main title, which would be hello world, right? And then we could manipulate this program and say that it has a body somewhere, or it has a block quote with a P, and this is some text, and then like a subheader of subtitle, right? And then we can manipulate this this data structure however we see fit to I don't know, produce PDF content, to build JSON graphs that we can load in applications like in JavaScript applications. There's tons of things we can do. If you're interested in doing that, take a look at this library, MarkupML by Tron. It lets you, well, its title is Error Recovering Streaming HTML5 and XML Parsers. Essentially lets you parse XML and HTML5 in a way that even if the file is broken, right, even if you have like a missing closing tag or like a syntax error or something like that, you'll still be able to parse the rest of the content, which is great. And that's a pretty good example, although I think this could be a little bit have a better resolution. Yeah, but it looks a little bit like this when you use it, right? You have some HTML, some string, and then you parse it, and then you get the signals, and the signals look like this. And you can use this to do anything that you want with the content. You can even preprint the HTML and just write it back and say, okay, I'm going to make a very tiny HTML preprinting tool with it, which actually is a pretty good idea for for a screencast or a live stream. One sec, I'm gonna drink some water. Okay, so we don't want to be opinionated about about how this is going to happen. We don't want to say that all of the posts should be wrapped. We also don't want to say that all of them should not be wrapped. How do we want to proceed with this? Well, I've been giving it some thought, but I've got to be honest, this is going to be a little bit of a stream of consciousness sort of process where I will just lay out some alternatives that I've been thinking. I'll try to explain why I think ones are good or bad, and maybe we'll try to elaborate a little on what we would have to do for each one of them. And I may forget a lot of things on the way. I may pick up on some cool stuff that I don't know right now about, that I haven't thought of before. But we'll see how it goes. So my first problem was that if I actually put an emoji here and I was trying to compile the Cactus README with this, right? This builds just fine. I have the emoji on the output HTML, but when I bootstrap like a static file server like SRV, this is just Python simple HTTP server, if I'm not mistaken. Then you can see here the folder structure is the same. If I go to public, and I have an index here, so this is going to be empty. But if I go to pages and first post HTML, then I see this weird thing, right, that I don't really like. What the hell is this? Although this is, I think it's an Icelandic rune, and it looks super cool. And the problem is that even though the document is encoded as UTF-8, this, when I mean the document, I mean this file. The document that this file describes, so the HTML inside of the file is not explicitly saying, hey, I am actually HTML content. So if we add the proper header for it, if we add a meta with a char set, UTF-8, right? And of course, if we don't compile again, because otherwise this still changes. If we don't compile again and refresh the page, boom, now we actually get a cactus. This is the macOS one. You might get a different cactus wherever you are viewing, whatever OS you're using or browser you're using. Not entirely sure how that works. But you get the idea, right? So I had the need to be able to specify this header. So I figured, okay, should I make all of the documents UTF-8 by default? That would be perhaps practical solution right now, but honestly, I don't know if everybody uses UTF-8 out there, or there is other languages where it works well. I am not an expert in char set encodings, in text encoding in general, so I can't really tell. But it felt like fixing it in UTF-8 would be like fixing it in ASCII and saying, okay, everybody that wants to use this tool needs to use ASCII, and that felt unnecessarily limiting. So I'm going to open here on the left a thoughts document, and we'll say like first thought is specify char set, no, like hardcode char set. And of course this was like nope, I decided not to do this. And then I thought maybe we can make the char set configurable, right? Char set configurable via the site file. So we have these tiny site files everywhere, you'll see, on each one of the folders that we actually want to treat as a site. For example, pages, but they're really empty. So maybe I thought maybe we could just say, okay, the file will have a char set rule that will just let you say UTF-8. And then everything inside of this site, which I'm going to save, which is inside of pages, right? So all of the pages will be treated as UTF-8. But to be able to do this, and this actually made it to the model in, if you look here, the site model and the type that represents the site inside of the tool, it actually has a char set, but I'm not using it at all anymore, or yet. But specifying it via config like this means that we need a default. So if it's not there, what should it be by default? And if you have a default, that means you will mess it up for some users. Maybe not the 99%, but I don't know. I don't have any users, so I don't want to mess it up at all, I guess. But also, it would mean that these little bits that we include in the posts, the surroundings of the body, the head, the HTML, and the meta, will have to be hard-coded by the tool. So when the tool compiles the markdown into this HTML, it will have to say, oh, actually, I'm going to put this thing around, and here I'm going to use the char set that you want. And if you start down this path, then eventually you'll have with like a title here, and then, sorry, title particularly doesn't make sense. You don't want a title for the whole site. You would want a title per post. But I don't know, like Open Graph set of rules where you say my description will be my awesome website, right? And then the image link will be, I don't know, like s3.amazon AWS blah 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 image.png and so on and so forth. And then that means some of these things will immediately have to be treated as configurations in your project rather than the template that you put the contents of your files in. So of course, this will add more and more complexity on the tool, and the more features we need, and the more flags or configurations that need to be added here will mean the more flags will need to be added to the model, and then eventually we'll have something that we will probably end up having something like meta tag, right? And then you get the name like char set, and then UTF-8. And if you get to this point, right, then why not just write the HTML tag and then a head tag? And then inside the head you have meta tags, right? And then you will have the body tag. And then before you know it, you're writing your whole document as a configuration here, which is, the same thing that you try to, that you end up having here. And that's because X expressions, right, are equivalent to S expressions. And the X ones are the XML ones, and the S one are the Lisp ones here. So you can write the same thing in both. So naturally going down the configuration will be too much. So as said, nope. By the way, if you have any input as you listen to any of this, just write it down on the chat. Preferably the Twitch chat. I know that it's a little bit shitty, but I don't know if you're on the functional programming Slack, or you're in Discord in the ReasonML channel, or if you're some of my friends in other to messaging apps. So it's easier if everything's in the same place. And then the next thought I had is, okay, maybe what I want is just to take the content of a post and render it inside of some template, right? So we do like a template, render post or document in template. And this is interesting because now all of a sudden we can define a template that essentially has, I'm going to save this file as pages template.html. We can define a file that has a template, right? And this is essentially what we want our documents to be rendered inside of. And somewhere inside here, we can just say like content, or I don't know. Like, normally we use these braces with the pipes for PPXs, for pre-processing extensions in the OCaml compiler. If you use any Reason before, you've probably seen things like this, which are for multi-line strings that support all sort of interpolations. If you use the GraphQL, you've probably seen that in here you can just say, hey, I'm going to do query, and then this gets type checked, and so on. Which, by the way, you should take a look at some of the work that Malin has been doing, Magnus Hallin, in GraphQL at PPX. Oh no, I missed the link. There you go. It's pretty damn awesome. I hope he has a GIF over here. Yeah, look at that. You end up writing GraphQL code inside of your Reason or your OCaml code, and it automatically type checks everything based on your schema, and it does auto completion. It's really damn cool. So I thought, okay, render document in template. Maybe we can start here, right? And if we make the template be essentially, what do you call this? A printf template, then it should be easy enough to just get something up and running. But of course, we want to be able to point the tool to the template that you want to use. So maybe if we have this file over here, right, we can also configure in the site that there will be a template, and the template name should be template.html. For the time being, we could perhaps make this automatic, so if there is a template.html file, then it gets used all the time. But I personally don't really like tools that have a lot of convention for me. I'd rather write a little bit more. Just, you know, maybe when you generate the site files, include it there so it's obvious for people and they don't have to look it up. Because otherwise, I need to already know how something works rather than reading in front of my face, oh, this is going to use this template file. So maybe we can render it in the template, render a document in template. Okay, so this looks reasonable, and this is reasonable coding after all. So what would we have to do? We would have to, wherever the site file is, look for a template.html. If we find one, we read it in, and then for every compilation, after actually for every document that we read, so in this case first post MD and so on, we compile to HTML and put that HTML in the template. This would be a very, very limited way of rendering a document within a template, because there's essentially just one spot where you can put something, right? Yeah, we might as well use something nicer than modulo, yeah, percentage %s. We can do something like document body or text or just document. I don't know, we can iterate over this. The point is, this clearly isn't really valid HTML. It has some text in here that when we read the string, we can replace with the actual contents of the compiled HTML, and this should be good enough. That does not prevent anyone from just doing bad things like this, right? But hey, I mean, we're all grown-ups, so do whatever you feel like, as long as it doesn't hurt anyone else. And that would be another approach. And the final approach that I have thought of, and this is the one I like the most, is to use literate Reason or OCaml. And this would mean that you configure a template file, just like we would in the step before, right? But your step, your template is actually reason code, which means it will actually be some sort of function, like it will call, like for example, print or build, right? And it will take some parameters. For example, it will take the project, so you have all the metadata about the project available. It will take the site, the current site, so you have all the information about the site, and you get a document, which means you have access to the current document. And inside there, you can essentially print whatever you feel like. And of course, this is the most powerful of the approaches, right? Because all of a sudden you have this whole ecosystem of tools ready for you to make your templates, which means if somewhere inside of your project you have this defined this module that let's say find next document, right? And you pass it in the I'm just gonna write the type signature here, and I'm gonna change the syntax formatting to reason. That did not help that much. I'm gonna keep it in HTML. And you have this function called find next document that if you give it the project and the site and the document, it will return you another document, right? And you have another one called find previous document that if you give it all the information you need about the project, the site, and the document, it will just figure out what the next or previous documents are. Then, right, in your template, you could say, all right, because we have a document and we have a project and we have a site, let's just render a link to the one before. So assume this is some sort of React component thing. We can say like previous document will be find previous document, project, site, document, and then we can do the same thing for the next, and I'm just going to replace here previous with next, right? And then when we render the A tags, we can just say previous.url, right? And then previous.title. And we can do the same thing for the next. And because this is compiled for every document that we have in our whole website, in our whole site, then you automatically get this build, how do you call it, this intelligence in your templates. Your template can figure out what the documents around it are and how to do navigation automatically between them. You could very easily check whether for example, if you wanted to render down a table of contents, you could just say, for example, if you grab in the site, you could just say, give me the documents of the site. And then for each one of those, you could just map them into an li element, right? Li and then doc.name. Of course, you probably want to do a link as well. But you start to get an idea of what the possibilities of working with something, a template that is really just code gives you. And a reason to do this is that your whole documentation, and by that I mean all of your documents, your website, your brochure pages, your docs, whatever you're building with Cactus, all of a sudden becomes a program. That's very, very powerful. Matthew Broderick has written about it extensively in his pollenpop.com, where he says the book is really a program. If my internet ever, yeah, there you go. Amazing stuff. I've actually referenced him a few times already in this live streams. If you want to learn more with typography, take a look at Practical Typography. I really liked it. Yes. Okay, so this approach naturally is much more powerful, but we don't have a lot of time today. I have about an hour and a half more, and I don't think we'll be able to come up with something like this, especially because what I think we should do is essentially look. Let's say we fix the name of the file. Look for a template.re file, and then we need to compile it somehow. And then after we compile it, we will have to execute it. So we compile the template, and then we would have for interesting. For every document that we pick up, we need to execute the template on the document, right? But first we need to compile to HTML. And then when we have the output, we just write the output to a file. And this little bit, the compilation of the template, is something that I'm not entirely sure how to do now. And of course, if we can compile it and we can load it sort of dynamically into the program, then that sort of works as well. There might be ways of doing this that are fairly straightforward. If you know of any, just let me know and we can explore it offline. So right now, what I'd like to do is take a look at the first one. And if we do get that up and running, then we have a good idea of what it would feel like to use templates, and then we can investigate how to do something really cool. Oh, and one last one would be that literally, like, your docs are a program, or yeah, where not just the template is a program, but every markdown file that you have is in reality just being parsed into a data structure, and then um, you need to decide what to do with it. Maybe kind of like the template might be close enough for it to not be worth mentioning separately. Yeah, I guess so. I'll just leave your docs.r program here. Okay, cool. We have an idea of what is it that we need to do. We have a few ideas of how to do it, and we've decided to take one. If you're listening out there and you think that we should do something else, then this is the time to talk. For a second, I'm just gonna check. Wait, I'm gonna close Telegram because it's personal and nobody gives a shit about that. A Brave Discord terminal. Yeah, it's cool. I'm just gonna go to the Slack and see if people are saying anything. No. All right. Cool. Great. Oh shit! I should have posted something in here. Liquid build. I had already started a live stream earlier today. Where is it? Second live stream. Where did I post that? Oh, recently, yes. Now we'll be adding complaints support to Cactus. Cool. All right. Let's get cracking, shall we? So this is the Cactus repository. This is the source. It's not too big. Oh my god, there's Pixel Hero on the chat. How's it going, dude? It's pretty small, and it's a lot of very tiny modules. The build graph takes care of figuring out how to build this, what we need representing the work that we need to do, and offering some utility functions to execute it in parallel and so on. The build planner is the one that goes around looking for the files and builds the build graph. Cactus is just the main module that orchestrates like calling everything, and logs has mostly logs to say, hey, this started, this finished, and everything's good. In Bean we have main, which is the CLI. This didn't have to be a separate module. I just wanted it to be separate so that the doing files are minimal. The compiler defines how we're gonna do things, like how are you going to compile a markdown file, or how are you going to create a directory. The model keeps common data types are used throughout the application, like what's a project and what's a site. It's a reference for what's what. And then the parser is the thing that reads files and prints errors. There's a folder called rules there that we can ignore. It's from a branch. It did not get deleted. Okie doke. So where do we want to start? I think that we want to start by, we can start by getting into the compiler and saying, all right, inside the compilation function, let's assume that we have something. Let's assume that we have some content, right? And just try to inject it in the middle of the writing. And if that works, then we can bring that content from a particular template. So if we do let template here, and we do HTML, and then we head, and then meta char set equals, I'm actually going to use multi-line reason strings here for this, and I'm just going to copy the thing that we had open. Okay, bear with me for a second. We wanted something like body or document, like that, right? I think so. Okay, I'm gonna copy these lines now from one to the other shell. No, come on. There you go. Cool. Now we have this template on the left here, and it's just a string. We can tell by the type on the bottom left of the screen. You'll see that below normal, that's where I get the type information. I know most of you that use more advanced or modern editors will normally see the type information in some sort of blurry lines here, like string. Code lens, I think it's called. I haven't figured out how to use it in Vim yet, but to be honest, it's not that big of a deal. Every time I say, hey, type information, just go bottom left and go like, oh, this is a string. Okay, cool, next. All right, so if we have this template over here, then after we get a string after the whole compilation process, and what we can tell from here is that it begins as a compile target. Again, the type is on the bottom left, and we extract the input path, and the input path is of a type fpath. It's a module for handling file paths. And then we read the file, which means we have a string, and then we pipe that into of string from the module OCaml markdown called omd. Or umd, I don't know how to pronounce that. OMD maybe, O markdown, OCaml markdown, umd. And then after we have this umdt type, which is an internal type that the module has, we can pipe this into the HTML function, right? Which will turn it into a string again. And that's great. This is the exact same thing that we're going to pipe into write file to, well, write this thing to a file. So if we do document here, right? This thing is a string, and we have a template, so we might as well look for a function that lets us replace something inside a template with something else. Yeah. What do we have in string? Capitalize, concat, create, map, split, sub, compare. I'm looking for maybe replace, set, nope. Maybe the str module has something. Replace first. Interesting. So So in replace first, we will pass in a regexp, right? And then we will pass some string and some other string, and we get a string back. And I'm expecting it to replace the first string, right? Everywhere that the matching regexp on the left happens in the right string. But before I continue, talking out of my ass, I'll just Google. So I know that the Unix docs I had opened recently, so I can just go into the OCaml manual, which is very useful, has a lot of stuff. Cool. And then we have the module as str, which stands for, I guess, strings and other things. So let's replace first, was it? Yeah, and replace first, if we click it, is the same thing as replace global replace. Okay, so let's go there. All right. If you haven't read signatures before in OCaml, they normally, because they have all of the types like this, they normally write documentation that includes a function call with names for these arguments as the first thing. So in this case, regexp is a regexp, temp1 and s are the second and third parameters, or the first and second string. And it says returns a string identical to s, except that all substrings of s that match regexp have been replaced by temp1. Boom, perfect. That means that if we do replace first, then it will work the same way, but it will just replace the thing once. So I'm thinking that we can pipe the HTML into a regular expression that I don't yet know how to write, but we'll figure out. We need to match on document on this thing, right? And if we find that on the template, right, we need to replace it with the actual document. Does this make sense? We have a regular expression here, which we need to fix. I know Pixel Hero has been doing some work on this in the past, so he might be able to shout out and say, hey, use this function, or this is how you build a regexp. And then for every match that we have in the template of this pattern, we will just write the document inside, which looks straightforward enough. So let's figure out now how to write a regexp. Yeah, and then we have the regexp. Okay, cool. There's a function called regexp that if you give it a string, it compiles a regular expression for us. Awesome. Awesome. It sounds that we can that we can just call this thing. So we can say regexp, and we give it a string of this thing. And I'm going to do a local open there. Oops, nope, that's not what I wanted to do. Help me, what's going on? There you go, that's what I wanted to do. So when we get the content in here, it's a string, then we will try to match on the template for anything that has the content name in there, document name in there. Okay, cool. So now if we compile the website again, sorry, I'm gonna build the tool first. And the tool is saying that it doesn't know where to find the str module. When it compiles, required module str is unavailable, which is all right. We just need to go into the compiler and say, all right, we need this module as well. Add something in the libraries. And as you can see, now we have a success. Yes, awesome. All right, So this is the path to the development version of the tool. So this is where I have the repository, and then inside of build, inside of build is where the do and build system has all this stuff. And in build default, then we have source, and in here we should go to Cactus and binary and main, and boom, that's where we have the executable, right? And if we do help, this works. We just need to call build here. And what we expect to see is that when we open the file again, actually let me open the file first, page first, HTML. We need to remove this stuff, right? I'm gonna save it. Just to be completely certain, I'm gonna call the stable version of the tool again. And then of course, if we open the file again, you'll see that it does not have any of this templating around it, which is fine. And now that we called in development version of the tool, then it should essentially have the template around it, or blow up if something goes wrong. Oops, sorry, my bad. I called help again. I should call build. Build, go. Okay, it took a little bit longer, as you can see, like 3 milliseconds more. Twice as much if you want. And boom, now we have templating. Awesome, awesome. So if we save this file, right, and if we essentially refresh it over here, then we'll see that the char set is set properly to what we wanted it to be set. That's great. Jättebra. Cool. So this will be a first, like an incremental step. And now the next thing will be to actually read this template of disk. And that's going to be a little trickier, right? So the first thing we need to do is decide whether we want to pass in the template to the compiler, right? If you want to build the template inside of the target already has the name of its input, the name of its output. So, sorry, compiler, if we go to rules, this is where we define what the compiler target is. And it's essentially an input and an output. We're only using it for the compilation unit that says compile. There are other compilation units like create_dir that just have a path, so they create a directory. So we could perhaps just say the template will be a path as well. But we could also say the template will be an optional string. And the reason for this would be that we don't want to read the template every time that we compile the target, right? So if you have 1,000 files, you don't want to read the template 1,000 times. You want to read it once. But then if we put it inside of each one of the targets, because each file ends up being one compilation target, then we'll end up storing this 1,000 times while we execute, which is also another idea. So maybe what we want to do is take a look at the model, and in the type that represents a site, maybe there we want to say template, and so there will be a path for the template, right? So we can read it once, and then we can just pass it in wherever we need to pass it in. But we can also say template contents, and this could be an optional string. So if there's none, actually, you know what? I don't quite like this. I would rather we just had a type for template. And the type for a template would be, we could just make a variant here and let's say unread or yeah, people. So we wanted to always include the path, right? and we want to get the contents only sometimes. But then we don't really know if the path is there or not. So we maybe want to do, just maybe want to do I don't know, unread, and then we take a file path in there, and then read, and we have the file path. Okay, template. Okay, this is, I think this is better. We can take a template that could be a file path, right? Or we can take a template that will be the actual template string. And this will be the file path, but also will be a string of the content. Either is any content. And if you have any better ideas of how to split this two so that whenever you open up a template value, you know exactly what you have and what to expect, then please shout it out. And then whenever we call compile, we want to give it the path for the output directory, but we also want to give it the template from the site. So we probably want to do model.template. And this would be the I don't quite like that either. Alright, let's just say that you will get for a template a string. We'll figure out how we get to that string in a moment. So this compile function, right, gets called inside of the exec module when you say, hey, please execute this compilation unit, and it just goes, oh, I need to create a directory, so let's call the rule for make there. Or, oh, I need to compile a target, so let's call the rule for compile target. But this compile here, right, it's just has the project right now. It should probably get access to the site as well. So if we do model site, then we can add the site here. Either that, or we need to bake the site inside of the compilation unit. One out of two. All right, let's explore how much it will take to essentially add the site to this compile function, and if it looks like it's a bad idea, then we can go back and add it to the compilation unit itself. And try it out on the compilation unit. Yeah, it might be that it's just fine here, or that it's bad, and then we go to the other one, and the other one is even worse. So the exec compile gets called inside of the main module, Cactus, exec compile. And in here, in this line 22, you'll see that we could compile on the project, because at this point, if you quickly scan the logs, you'll see that at this point we already have started to compile the project. We have created the build plan, and we're ready to start actually compiling stuff. So now changing that signature means that this function over here will behave differently. Now, 1 second, because we get inside of the rule, we get a template. I'm following the error that we have here on the bottom right. Then we need to remove this template from here, but luckily it's already available. And this is a very hacky way of doing it. So I would like to encapsulate this logic somewhere else than inside this rule, but we'll get to that in a moment. All right, so now the next error that we have is rules.compile target in the compiler exec file. So if we go to compiler exec on the right, line 8, it says, oh, compile is expecting more things than you give it. And that makes sense. That makes perfect sense. So at this point, right, the compiler is expecting us to give it a path, so you can see on the bottom left. I hope you can see on the bottom left. I'm going to go back to Twitch and see if the stream makes sense there. Yeah, great, you can see. Cool, awesome. Yes. But we give it the output directory, and we're not really giving it the template. So the question is, at this point, we have the site that has a template there, right? but we need to choose whether to read the template here and to pass it to compile, or to instead pass the already read template into compile. So again, I'm going to make the decision of deferring this thing one level up. I also, yeah, I know I don't really like the way this is starting to look. The parser now is complaining that the template is not defined. All right. So the parser module is this tiny module that's meant to stand in as a mock, sort of, for reading the files and checking the contents. Right now, the only thing it does is for Cactus project files, it makes sure that the file exists, and then it returns a dummy project that has some information that from the disk. But for the model, it just returns a model that has a fixed charset. And again, we're not using this charset anywhere. If I show you the matches that we have on the whole code base, you'll see that we only have the first one is nope, does not hardcode the charset in the thoughts document that we saw before. The second one is what we just saw in the parser, and the third one is the definition of the charset field in the site type inside of the module model. So we're not using this at all. But now we need to define a template. And as we saw, the template will have a path, and the path should be template.html. And we're gonna leave a to-do for myself to come back later and actually read template from the site file. Cool. So this will give us access to the file name, assuming that we read it from somewhere. We can fix where we get it from, but now everywhere that receives a site, a type, a value of type site, will have access to a template. Okay, so now the next thing we need to figure out is where the hell are we actually calling this compile, exec compile. And we saw that in the Cactus module, right, we partially applied it with the project, and then we seem to be passing the rest of this compilation function to, this is gonna get interesting, to the function that will compile each one of the files sequentially in the sub-process that will do the work in parallel whenever there is more than 50 nodes in the graph of execution, or there is more than 0 jobs specified in the parameters. What the hell does this mean? This means that when we run Cactus build, right, the first thing that happens is that I'm going to use verbose and debug. It means the first thing that happens is that we create a build plan, and this build plan decides that, okay, we need to make the public folder, and after the public folder is completed, then we need to create this other folder over here, and then after that folder is completed, then we can start compiling the markdown files, right? This happens here because it's a small project sequentially, meaning that if we run it again, then we'll see the same order every time. And you can tell that I'm running the same command and it occupies almost the entirety of the terminal. So the output just replaces itself and it's the same output over and over. That's fine. Now, when I pass in jobs, right, and I give it a value of over 0, like for example 8 or 4, let's go with 4. This branch of code on the left, if you look at the left side of the screen, you'll see that this part, right, is the one that will be executed instead of this one over here, which is the sequential bit of code that we just ran. Which means that when I run this command on the right terminal, then and only then you'll see that the output sometimes looks different. Sometimes compiles the files in a different way. So I'll run that now. And I think that okay, no, well, my bad. If we remove the condition on the size, which is a small heuristic that I added, then this will run in parallel. I'm sort of disappointed, but yeah, the point is that for a bigger site that runs everything, that has more than 50 compilation units, this one has only 12. It will actually run in parallel, and we can double check that that is not a lie by going into the here. If I go into the examples, and I'm going to make this window big, I can run Cactus build with jobs 8, right? And then you'll see that this takes a fairly short amount of time, a little over a second. And when we open it up, we'll see that there's tons of outputs being built. There's about 407 compilation units. This is 406, maybe 404 markdown files being compiled and chunked and sent into a worker pool that does that work. Anyways, less important, but works. So we need to figure out how the hell to pass in the template content to each one of these execution modes in such a way that we read it only once. So for the sequential mode, which is the one that we're using in the sample website that we're running, here, let me just go back to the command, there you go, here, right, then it will be fairly straightforward. We could just hack it in here and say, okay, read the template file, that's all. For the parallel one, it becomes a little bit convoluted. Why? Because at this point, right, we only have access to the complete graph. By that I mean we only have access to the root node and a list of nodes that are dependent of it. So we can't quite just go around and say, find me all of the template files, I'm going to read all of them. We sort of have to start reading the template file immediately before we start working on a particular site. Otherwise, we'll have to traverse the whole tree once to build the computation graph, and then traverse the computation graph to figure out which one of the files are there. So this is making me think that maybe we need to read the templates a little earlier. Maybe we need to read the templates when we're planning the build. So if we go into the build planner, the build planner essentially over here at the bottom, right, begins by saying, okay, there will be a build node. And build node is some work that has to be done, and it contains both a target, which is what kind of work has to be done, but also a list of dependencies, like next step to this, next step to the other thing, so on. So whenever we call find sites, we start crawling the file system looking for files that will be documents and files that will be templates, and we read the site files. If we find one of them, then we actually build a new node and say, oh, Because this folder had a side file, you'll see here a debug log, and you can also see on the right hand side of the console when it says creating build plan, it says, oh, found a side file at this path relative from where we are right now. Oops. And it also found 2 other files, and it found 1 document. And then, oh, found a side file inside a pages site, and then also inside of new project site and sections, and so on. Which means it will immediately just build this node that we see here in line 32, right? Where it says, okay, because this is a site file, then we need to build a folder for it, and then for each one of the documents that we found, we need to be able to build them. So at this point, we have the site, right? Which means at this point, we have a template. And the type checker is failing me here because I messed something up in the parser. So let's go to the parser and fix that. And after we fix it, then we can be good. One. All right. Okay. Sorry. So we make, okay, so this is complaining because we're trying to pass it in an F path, and this is an F path, which should be good. Unless this file comes from somewhere else that we don't know about. But we define this file inside of the model. So I think that we should have it. Oh, wait. Cool, that worked. Because we did not have the model open, and for some reason, this local open did not do what I expected it to do. Yeah, if we don't actually do the open there as well, it just says, oh, I have no idea what you're talking about. Anyway, let's go into Cactus RE, and let's go into line 26. And that's my bad. Ignore that compilation error. That's exactly why we ended up going into the build planner to make sure that wherever it's that we are, we can take a look and open. Why can't I open the? This should be a model.site. Huh. So it is a model.site, but for some reason it's not letting me out to complete the template out. Interesting. Right. So I kind of have an idea of what we could do instead, because if we read the file here, then we can include it in the compilation target already, where we have the input and the output, which means we would not have to pass it in the compile function, and we would not need to pass it onto the rule, the compile rules. It will be available by saying target.template. I don't know. I am not very comfortable with this. I think that it may work, but it's kind of ugly to have to pass around this string, this template, which is not very big, right? But still, we have to pass it around everywhere. We could also read the file on every worker, but since we don't really know when each one of the files will be executed in each one of the workers, then we cannot have to read every time or give all the templates to all of the workers so they know what to work with. And I think the main problem with that is that we may not be able to ensure reproducibility. I don't know. Okay, let's give the other approach a shot. Let's say that instead of passing in the string to the compile and passing in the template, we essentially have target.template. So if we go into the rules, then the compile target will also have a template here, right? And this will be a string. It's already built for being compiled, for being templated over. Which means that everywhere where we have built one of these templates, we will have to modify it. But let's begin with the compiler errors. Template. Can I ignore the rest? It looks like I can. Okay, perfect. Let's go into exec and say there will be no string here either. Everything stays the same. Again, the reason for not passing it directly is that if we start to pass in more things, then the compilation unit will not be self-contained. The compilation unit itself will end up having just very little information about how to actually generate the output based on the input. It will end up saying compile this markdown file, and then some other thing that we don't really know about will be doing the templating. At the very least, even though it would be a little bit inefficient to pass around the template on each compilation unit, then at the very least, this value tells you there will be an input, there will be an output, there will be a template. These are the three things that are involved in templating the inputs and compiling it to the output. So it's a little cleaner, but we need to figure out later on if this is gonna pan out well or not. So I'm just removing now the references to that explicit template that we had before, and then okay, the last thing that we need is if we find a site file, then we can do template, oops, equals base OS read file, oops, and then we can pass it in the template from there, and that will be the string. And then we can just say template. So in line 31, site.template perfect. Okay. Remember that back in the model we said the template can be either a file or a string. We're gonna take that back and we're just gonna say the template will always be a file path. At this level, if you have a site, then template is a file path, but if you have a compilation unit like we have here in the rule, then the template will be a string. Okay, so that means that minus the error that we have in the module file, and an error in the parser where we were using a variant that no longer exists. Okay, I'm leaving the comment in there. This compiles. Great. Which means that if we go into the rule, right, then because the rule gets the compile target and the compile target already has the template in it, then if we run the original tool, right, over, which is super fast, and we see that there is no template, and we run the new tool with the new feature over, which is also very, very fast, and if we open this thing, we'll see that, boom, it's broken. Brilliant. It didn't do the thing I expected to do. Awesome. Why? Why will you do this? You can have a look by going to the source here, and we can say like templated, and we can print something out. Debug, templated. And this should be, I think I know what it is already. I think the problem is that when we read it, we're not reading it from the right place. Here, right, when we do read it, template will just be the hard-coded string from the model, right, that we put in the parser, which will just be template. But in reality, we want to use the dir with the template to be able to find that file. The dir is essentially the base folder where we can find this site file. So if your file is located in page site, right, then it would be essentially this pages, which makes sense. So let's do that first. Let's take the template and let's append, and we're gonna append the site there, and then we're gonna try to do the reading. Read the file. So if we compile it again, then we have the template there, which is a little nicer. Now, normally, if we were to verify every file, then we will end up I mean, we could have hundreds of thousands of files, so it will be unlikely that we verify. So in the future, whenever we do modifications to the compiler after this, we will be using MD5 or another checksum mechanism to make sure that the output didn't change if it shouldn't have, or that it has changed. There's also the very useful output for no files, right? Which I've encountered many times in the past, and I always forget which one is it, but I think it began with D41 2070. So the next time if we run this thing and we get a D41, we're gonna go, shit, it's empty. There's something that went wrong. But we have the first step there, right? So that we don't mix anything, we're gonna make a new branch, and we're gonna say feature, and this will be add site templates. And the next thing that we want to do is to actually be able to, because remember that this template is in disk right now, right? Pages template, right? This template is here on disk. If we did 2112 here, UTF 2112, maybe 2,000 years from now, and we compiled the project again, right? Then when we were to open the first post, we will see 2112 there. So we are 100% using this template, which is great. Now the problem is that the name is hard-coded, and then we're not really reading it from the configuration. So if you had another file called template HTML that you use for anything else, then this convention, air quotes, will get in the way of however you're building your documentation or your website, and that sucks. Tools should not get in the way ever. So let's put the template back into 8 so that it works, and then let's go into site and figure out how we're gonna do this. We can add a rule here called template, and I guess we could make this kind of flexible so that each file could specify the template that they need, or multiple files. So we could make this be a regex and then the template name, right? And this could be a list of those. So we just say like a regex2, and then template2, and regex3. So to me that looks like a more scalable approach for the templates, where whatever it is that you end up doing, be different sites, different sorts of posts, or different patterns for the naming of your files. Let's say some of your files that end with like post should go into a template that goes like a post template, right? Or anything that has a number in it, or like let's say just like a mail, and this would be like an email template, HTML, and then everything else just go into the default template. However, we could also assume that the default use case is going to be the most common one, and when we parse, we could check. If the first thing that we read is a list, then great, we know we have one of these things that has pairs of regexes and template file paths, which, by the way, this could be anywhere in this. This could be like templates folder above. This could be a hidden templates folder. This could be wherever you feel like. You start to get the idea of how this literally lets you configure the entire architecture of your site without, without having to force yourself into any sort of convention that anyone else that came up with. It's like literally fight dogma. Configure things however you feel like it. But if we don't find a list, then we expect the first element to be just a template name. So we could say this, right, should be equivalent to template this, right? And if you have more templates that you want to use, then you can just expand this little thing into the list of templates and use all of them. Okay, so let's assume that this is the rule that we want. Now, this means that we need to make changes to our parser. If we open our parser right now, it doesn't quite completely ignore the path to the file, but it certainly does not try to read the file. So let's take a look at that. The first thing that we should try to do is, well, read the file. And we can use our base OS read file path to get the file out of there. Contents. But the contents aren't quite useful for us right now. what we really want to do is parse this thing. And because I am choosing, I know it's not a very popular choice of syntax for let's say the JavaScript or the web community, which would perhaps rather have JavaScript saying config and an object that has like a template, and then in there have like either the name of the template or uh, an object that has the pattern and then the name of the template. But fortunately, or rather unfortunately, I like sex expressions. Sexpressions. That's how you pronounce them? I don't know. Anyways, and OCaml has brilliant tooling for dealing with this. In fact, if I open any of my Dune files, you'll see that my Dune files actually look a lot like what I was just writing on the right. You know, you have this library that has a name that may have sub-libraries inside, and so on and so forth. So it's a well-supported well-supported format for writing files in, for reading files, for parsing them and making sense of the contents. So we're just going to use a library that does some of those things for us, so we don't have to implement any parsing at all. I got a one thing over there. I don't know what this is. Notifications. Ooh, 9 achievements. Damn. I don't even know which those are. All right, and this library is called ParseExpert. No. Yeah, ParseExpert. I should start with stuff I like. By Jane Street. It's a S expression parser. It contains functionality for parsing them, and it has an API for doing so. If I find a link to the doc somewhere, I can't find the link to the docs. But as it's normally best, we can just get into the actual interfaces. Okay, so this is private. Parser, gen, CST, import ML. Parser automation. Where is it? Where are you? Okay, JBuilder. Okay, so this means that there will be a parse expression, parse module somewhere if I include this in my project. So I already have included it before, but now it's on here. Okay, so let's include this. I'm also gonna sort the imports, and let's install it. Let's pam install parse. Cool, I already have it installed, which is what I expected. And if we go to the parser and we open Dune, we already had it included as a dependency, which is great. So let's just go open into the parser code and say parseExp, and then we have a bunch of parser modes. So each one of these are modules, and there's just a bunch of modules. And what we're trying to read here is, oops, sorry. Many, I guess. We could begin by parsing just one, a single one, and see what happens, and then changes into many when we have more than one expression inside of site. But we also want this thing to not fail miserably if there is a parsing error, because you don't need to specify what your template will be. You maybe don't have a template. And if you don't have a template, then what should we do, right? Okay, so nice. The single parsing module has a parseString function that will return either the results, the eagerly parsed value, or an error, which is great. So if we type this in there, then the thing that we get out of it, right, it's a result. So now we have a result of the parsed value and something else. So a very basic first step could be switching on the contents and saying, if we have, actually let's take a look at what the hell this type is. Parsed values, parser eager parsed value. Huh. Okay. So if I go here and go to eager parsed value. By the way, this library might not be a testament to readability for us who are not very familiar, but it's my understanding that it's just ridiculously optimized for performance. So that might explain why. For us mortals, it might not make a difference if you parse the file in a few hundred milliseconds or a second even, but for Jane Street naturally, it does make sense to make something that runs really, really fast. They require that. So we're looking for a type called parsed value. And I see there's a functor for making something called make eager. So I'm going to look for that one. Great. And somewhere, okay, so each one of the modules that we're trying to import is available here. So somewhere in here, there should be, there you go, single, parse value, sexpt, and if we go for sexpt, this should be defined somewhere here, and I think it was actually in the README that they say what the type is. Yeah, there you go. All right, so either we get an atom, right? That is either the file that we're parsing looks only like this first line, like WAP, right, ASDF, or we get a list. And if we get a list, then we have two atoms inside of it, which makes sense. So we're hoping that if we're reading contents and the contents are okay. So if you're reading the contents, right, and I really wish we had a monadic result map here. Okay, error. No. I think I have something for this result map index. Right, yes. Nice. Thank you, Leandro from the past. Parser. Right. So what I did there was I'm going to open a module called base result infix, which is defined here. And the result infix just defines this little operation, which is really not a map. Oops, yes. This is the wrong name for that. It should be that. Yes. So that once we read the result, right, then we can just essentially do map, and then we get the values inside. And depending on what the values are, we'll do a switch and we'll say switch values. And if this is an atom, then we don't care what it's in there. We're just gonna say this would be none. And you'll see why in a second. But if this is a list and it begins with template, and the second thing is template with HTML, then we'll say some template.html. Well, I'm sorry. This should be a variable name. Template. 222 template name. So if we find any single word like hello, we don't care. Like there is not a path there. There's not a template path, right? If we find a list that has 2 elements, and only 2 elements, then we'll return this and we'll say, okay, this is good. This template name should be a file path, but anything else that we return, it should be none, which of course means that we can remove this. Only when we find a list that begins with template will we actually get this thing there back. That's fine, that's a start, which means that after we have mapped values inside of this result, and I don't know why this is complaining. There you go. After we've done that, we can map again, and we will have a maybe path. It's actually a template, really. Maybe the template is none, and maybe the template is something. Ooh, I love when the reformatting just restructures my code in a way that looks cool. All right, so this means we are reading from this particular file, right? And we're reading the template name into a variable. If we find one, then we have something, right? Sorry, here, something. If we don't find what we're looking for, then we have nothing. Now, this is not intending to be an extensible parsing mechanism. If we define another function here, like don't publish or like private true, right? Then this is just gonna ignore that completely. It's just gonna parse the first line, and if the first line is exactly what we need, then it's gonna say some template or not. But that's okay because this is very, very self-contained. The code that runs read site, right, has no idea what the syntax or the semantics for this site file are, and it should not know. The connection between the rest of the application and the file should always be the model. Speaking of which, the model that we had before is now outdated because now we have a model that may or may not have a template. And I'm gonna pause for a second. My sickness is getting the best of me. Okie doke. All right, so now we have something that kind of works, but we need to refactor this model. So let's go to the model and say the template actually will be an optional path. Yeah. And it's also likely that we need to do this. Let me just see. No, this doesn't re-export the types. Okay, so we just need to import that as a module. So if we go into the Dune file of the parser and we do sex. Now we can try to install this. Okay, so the name of the library was different. Was it different? So if I do this, Did I have a? Oh, yeah. Huh. Yeah, that's exactly what I wrote. Yeah. Line 32. This pattern matches on this thing, but a pattern match. Oh, all right. Okay, perfect. Right. This thing inside doesn't actually have strings, it has atoms. Hopefully this makes sense, right? Inside of a list, you'll see that the type that we have is either another list or more atoms. Go back to the docs here. It could either be an atom that has a string inside, or it could be a list which has a list of T, which is the same thing. So it's a recursive, inductive data type. Cool. So now if we have an atom that has a string template and an atom that has a template name, then yeah, we'll get the template name out of there. So now in line 33, it's telling us that some does not belong to type and that's okay. I think the problem may be yes. The problem may be how we define this function. Because map over here, oops, my bad. I'm going to close this little view on the left. Map over here is defined correctly to change the value of an OK when there is an OK. Huh. This is confusing. So if we take a function from A to B, let's see what happens if we don't use the operator. So base result map. Same error. Okay, so clearly there's something wrong with the function, which I wonder why did I even have it in the same place if I haven't used it. So here is a result from what? B to C. The value should be a B, and F is from B to what? Why? This is confusing. No, F should be a function from A to B. Okay. I might be able to use, yeah. Yeah, okay. I think this is what I'm going to be using instead. I'm going to use the R result module. There we go. And that worked. So this R result is a collection of, I'm going to remove the stuff that I'm using. Oh, I am using this in the index module. It's a collection of result utilities. I think they come with BOS, which is a basic operating system library by Daniel Wensley. So if you go to, I think I have BOS open somewhere here. Path, here, BOS. Up, up, up we go. BOS. Yeah, depends on our result, a string, format, path, logs, and the OCaml Unix library. If you want, if you want to use any basic operating system utilities, have a look at them. Daniel Bernsley makes amazing libraries for OCaml. I'm actually depending on so many of them right now. I depend on, where is it, fpath and logs and fmt and results, and also, where is it, the command liner. Holy shit, these are a bunch. He makes really good stuff. Anyways, so now we've reached the end of this function, right? Where am I? But now this function returns it returns a result where it used to return just the site, which means anywhere that we're using it, we need to change that as well. So if we go into the build planner and we try to read this thing, we'll see that, oh, read site, as we see in the error, line 29. The error might need updating. Right, line 29, you're trying to access .dir out of a result, and what the hell does that mean? It's just, it doesn't make sense. So what we want to do instead is we want to switch on this thing, and we want to say if we have an error, right, we're going to be calling the logs.error call, and this thing is going to be something went wrong reading the site file, and we're going to put in the path, and we're going to put in the error. And for the path, we have the site file, and I think this would be, if I'm not mistaken, an fpath, so we can make it a string. And just for the auto-completion to work, yeah, do that there. And for the error, which is parsecs error, I would like this error to not be handled in here by this library. I would like this error to come already as a string that we can just print out, so that all of the parsing errors that we have internal to the parser are handled in there, and then on the outside you just I guess you don't have to deal with that at all. So let's take a look at what the parse error.t could be. Somewhere over here. Nice. So we actually have a function for reporting these errors called report. And it will get a pretty printer formatter that will decide how to do this thing. So I actually have not worked with this kind of pretty premium formatters before, as you've seen possibly in some of my module documents, like rules. I still have a to-do here to rewrite this thing to use fprintf instead. So I don't entirely know what's going to happen. So what we could do right now is well, we can see what operations are available for us in our result package. We have error to message, fail. We have open error exception trap. Whoa. We even have an infix module that doesn't have an alternative operation there. So what I'm wondering is, let's make this big to see all the signatures. How can we map over the error? Fail error to message. This will get a printer. Okay, let's see about this one, right? We have R and then error to message, and then the signature of this thing, oops, was it takes a PP error function, and this function I think we can actually get from parseexp. Parse error, then oh, okay, this is even nicer. But I guess report will also work. We give it a file name, we give it a path, and then it will use the reporter from this thing. Cool. Okay. So report, when applied to the path, it takes a formatter and some parse, some variable, right, and returns a unit. An error to message, when applied, what it actually expects you to give it a function that has a formatter and a parse error and returns a unit, which is exactly what we needed to give it. And then if you give it a model sign with a parse, this is perfect. That's exactly what we wanted it to do. Now the problem is that it's returning a result, so we should collapse the result from before with the new one, and we can use the bind operator, which in other languages is flat map. Yeah, cool. So line 47, the file path actually just needs to be a path though, to string. What? Huh. Oh, okay. So the fact that we were using some of the error there, it's actually telling the file system that we need the, oh, what am I talking about? God, the type system that we need an error somewhere. This is confusing, but also it's getting late. That's how I justify my stupidity. 47 line 8. So 47 line 8, there's this function called error to message. When we apply with a PP, then we get a function from a result to result. It doesn't care about the left-hand side, which is okay. Oh, right. It's just I just need to pipe it in. There you go. The confusing part was that I expected this to work as, let's say, a combinator, so that the reality is that it needs to work on the full of the promise, in the full of the result to be able to map over the error as well. So if you don't give it the whole result, then it doesn't know what to do with the error. And the fault was that the bind operator actually just has the good stuff here, right? It doesn't show you what went wrong, which is fine, because now if we switch, we switch on this file, and we should probably do this as fast as we can. So if the file exists, and we can read it, it's either true and we have a site, right, there, which is great, or none. Okay, site, cool. Cool. Line 29, site template. Right, and because we made a template optional, now we need to just continue this refactoring. Which means that if we do have something here, then we want to map. So I wonder if we have some module for dealing with optionals in the same way. Maybe what's this? No, ooh, this looks like object orientation. Option. There isn't an option module? Huh. Okay. So I'll just cite on template. If we do have some path, right, then we'll essentially just append the path. Oops. Sorry, I get clumsy at this time of the night. Cool. Ugly. I don't like switching like this, especially when there's abstractions for it. So you know what? Let's just do that. Option A. I still wonder, maybe just maybe. Path. Maybe he's written something like results for optionals. No. Well, okay. This is the fast thing, and let's just make a small option module. And let's just do a map function there, and the map function will essentially be this thing. So let's call it map, and then just take first you take a function, then you take a value, and then if there is no value there, then you just run the function of the value. Else you do nothing. The last thing we need here is to actually make it a function, and boom, there we go. Base option, open it. Awesome. Awesome, awesome. Great. So far so good. We have a template, and if the template is there, then we will have a file read in, and if it's not there, then we won't have one, which only means that now the compilation unit in rules also needs to say, well, there may or may not be a template, so we box this in there, and that's fine. Last thing we need to do is just switch on the target.template, and if we do get some template, then we will use the template. Else, we'll just return the document unmodified. And bam, that worked. That compiled, which makes me think that we could try to make this not use the template first. So let's remove this from the site, right? I'm gonna open a small terminal below. We're in the website here. We just modify the site file. If you go into pages site, it's completely empty. So if we run the compiler, oops. Okay, well, I guess I'll have to do this manually. Or I could just close and run it up there. And I'm running it up there because I already have the path. So if we run the compiler again, then we expect to see the files. Okay, this was too fast. This was just too fast. And this probably means there's something wrong with the way that we are reading the thing. So in the build planner, we could essentially log this out, right? If it doesn't really matter what we have, if we have a site file but we have an error with a message, then we can just say logs error and something went wrong. No, error parsing, and then the name of the file, and then we also have the error there. So site file, path to string, and then error. Sorry, message. I think message is a string. Cool. So if we found an error parsing the file, even though it exists, then we want to log it out and know that, oh, something went wrong. So this should say, oh, look at that. Ta-da, no S expressions found in input. Which kind of breaks the magic of just touching the file and getting the site there. So we need to figure out how we fix that in read site. So the parser, I wonder if there's a parser that will parse something, but maybe doesn't find anything. Like many Right, okay, so the single parser parses a single S expression, 0 or more is an error. But we can use the many parser that has multiple of them. Return as a list. So I guess we can use many, yeah. And if we use many, then the values will have a list, but we only care about the first one. Cool, so that builds, and if we run this, oh, now it works again. Nice, awesome. That means we have read the file. We actually have read the file. I'm very happy for that. And if you want to make sure that we are writing the template file name, we can also put here, and then we do template name. So we run this again. What? Oh, my bad. I always forget that this library for login has been so well designed that you actually have to pass in a function that will be called if the level of login is precise, is adequate. Okay, so now we should see template somewhere. Wait, did I compile? It compiled, so we run it, and somewhere in here it should say debug template file. Okay, it's not going to say anything because the file doesn't actually have a template. But if we open pages site and we say template and then hello world, right? It's just the weirdest way to actually do hello world here. Just writing the tool again, we'll say, oh well, I'll be damned. I was expecting this to work. Creating build plan. What is going on? If you manage to hear anything in the background, that's parts and recreation. So much fun. Okay, so that worked. And I think the reason is that the pattern match that I had before here was matching on a list with two things, but in reality we want to match on a list that has more than two things. So it doesn't really matter how many things you have, we'll just take the first. And that works too. Cool, look at that, hello world. Now, of course, because this template is non-existent, if we try to open public first post, then we'll see something like that, right? Why? Because the template file is empty, which means there is no instance of document anywhere where the document can be put. Sad. However, because we are reading from file, from disk, if we put template.html here and we run the tool again, and this is just changing the configuration, not recompiling the tool at all, and we rebuild, then opening the first post should, boom, show the template. And thus, we have enabled the first feature of Cactus beyond being fast for a very tiny site. And this feature is templating. There's a lot of work to be done in making it both super nice in the parsing side and super nice or super efficient when it comes to parallelizing the work, because right now this will copy over the template to each one of the workers that it's using with each one of the compilation units. We can take a look at how much slower it is very quickly. Let's let's close this thing. Let's close this beautiful template, and let's go back into the Cactus project. So if I open a new terminal and I move it up and I close the little website, there's an example website here that has, as you may remember, 809 files. Half of those are the output, half of that is the input. There's a lot of markdown files, and it's not a small mark. It's not like a few bytes of markdown. It's about 16 kilobytes each, which is a fairly lengthy blog post. And we can go into blog and site and say, oh, template, and use the template HTML file. Boom. And then we can actually edit the template now and say, this is a template. Well, actually, I'll just, yeah. And we just put, what was it? Document? I forget. Oh my god. Could I forget already what this was? Okay, so if we run Cactus build, the regular one, then if we open any of the public blog first HTML files, you'll see that it's just the content. And now if we run the development version of the tool that will pick up this template, oops. Now I expect it to be slower than 2.1 seconds. This time is also very variable, but I don't expect it to be that much slower. Okay, it's like a tad slower. But if we open this thing, then we'll see, boom, this is a template. So we are able to template, and we should also be able to template across folders. So we could easily just have like a templates folder, right? So we move the blog template into templates as blog.html, or like blog post HTML, and then we can edit the blog site and say, you know what, actually from this file just go one level up into templates and use the blog post HTML. And we can change the template so we know that it's going to use it. So templates, blog post, and we can leave a template that kind of works here. So we do HTML, and then we do a head, and then we do meta, charset, UTF-8, head, and then we can do body in and body out and HTML. Okay, so now we have a new template, and if we run this thing, boom. And we can open the output in public blog 1, and we're using our new template. So yeah, okay, cool, awesome. This works. It would require some refactor, but I can open a PR now, and I can start thinking about what would be the best way of going at it. We've seen quite a few things. We've taken a look not only at how to read files, but also how to parse S expressions or Lisp-like config files or files in general. We've also talked about trade-offs between keeping work self-contained, when we talked about whether the compilation unit should know about its template that it's going to use, or whether we should just pass in the template as a side input to this compile function, and I think we made the right call by keeping it there. We are aware of the trade-offs. I guess that's the same thing. What else have we done? We can look at the diff. The diff is not that big, actually. Yeah, and ultimately we've evaluated alternative implementations for this feature. Yes. Okay. I think it's been a really good 2 hours. I hope you learned anything or something from this. It would be very nice to know what, if you liked it, what was it, and if you didn't like something, then also that. Unfortunately, my workflow is a little bit uncommon. There's no a lot of VS Code or automatic building happening for you in a modern IDE. But other than that, I hope that jumping around terminals was not as bad as it looks when other people do it. And yeah, I wanted to thank my mom for bringing me to this world, and go eat ice cream and build cool things with Reason and OCaml. All right, stay reasonable. This has been Reasonable Coding. We've been working on Cactus, a composable static site generator. I hope you liked it. Go start it if you think it's a tool that you like to follow. I'm going to be working on it on my spare time a lot. So if there you go, this is the site. Boom, boom, boom. Have a look. Enjoy. Take care. Bye-bye. Oh yeah, and also let me know if the quality of the stream is good. See ya.